Hey everyone, and welcome back to AI Paper Podcasts. Today we're diving deep into a paper that honestly has the potential to totally change how we think about training these large language models.
Yeah.
So imagine this, okay? You're training an LLM to reason like ChatGPT, but you don't need ChatGPT to do it.
Right.
That's what Bolt aims to do.
Yeah.
Bootstrapping, long chain of thought. And it's pretty wild.
Okay.
So we're going to be looking at the Salesforce AI research paper, Bolt, Bootstrap long chain of thought in language models without distillation.
It's a super cool approach because it solves a major challenge we've got in the field right now.
Yeah.
If you want to build an LLM that has this really sophisticated step-by-step reasoning, what we call LongCoT, you pretty much need to have existing LongCoT models to do it. It's like you're trying to teach a student advanced calculus,
right,
but you don't have a calculus textbook.
Yeah.
Or a teacher who knows calculus.
Exactly. So you're either stuck paying a ton of money to access these models, or you're trying to just figure it out from scratch.
Yeah.
Which is...
Right. And even if you can get access to those models just relying on those limits, what you can do, it's like you're always following in someone else's footsteps. You're never blazing your own trail.
Yeah, it limits the innovation for sure. So Bolt seems to offer a way to get around these limitations.
Totally. And the really cool thing about Bolt is how efficient it is. Instead of needing huge data sets or paying for these pre-trained models, it uses just a few examples to kind of bootstrap the LongCoT reasoning abilities.
So you give it a few examples of what good reasoning looks like and then let it go from there.
That's it. And what's crazy is that it works. They showed in the paper that just 10 examples is enough to get an LLM to make those longer chains of thought. And they tested it on all sorts of stuff, coding, math, searching for information, even creative writing, and it worked.
Wow, so that's huge, right? Because it means we might not need to keep making these models bigger and bigger with tons of data.
Yeah, maybe there's a better, more elegant way to teach reasoning.
So for our listeners who maybe haven't heard of LongCoT before, what is it and why should they care?
Okay, so you know how LLMs work, right? They can write, text translate languages, answer your questions, but they don't really reason on a deeper level.
Yeah, they can give an answer, but they can't explain how they got there.
Exactly. LongCoT models can break down these complex problems into steps. They analyze plan, come up with different approaches, and they can even backtrack and fix their mistakes.
So they think out loud, show their work.
Exactly. And that helps us trust the model because we can see how it got to its conclusion.
So Bolt gives us a way to make these smarter, more transparent reasoning models without spending a fortune.
Right.
That's awesome. But how does it actually work? It's a three-stage process, right?
Yeah. It's like boot camp for LLMs. The first stage is LongCoT data bootstrapping. They start with an LLM that's already been trained on instructions. In this case, they used Llama.
So it's like a recruit who's finished basic training but now needs to learn special skills.
Perfect analogy. So then they show this model just a tiny set of LongCoT examples, only 10 in the paper. And these examples show different ways to reason, giving the model a taste of what it's aiming for.
So it's like showing someone a couple dance moves and then they have to choreograph a whole routine.
And surprisingly, it works. Just those 10 examples are enough to get the LLM to start generating its own longer chains of thought. And the variety of stuff they used is really cool. Coding, math information, searching, creative writing. It's like they're showing the model all these different ways to think.
From just 10 examples. That's mind-blowing. So what's next? Do they keep giving it more examples?
So stage 2 is LongCoT Supervised Fine-Tuning. Now they've got this data from stage 1, all those chains of thought the LLM came up with, and they use that to train a new LLM. It's like giving it focused practice.
So it's going beyond just copying those initial examples. It's learning how to reason on its own.
Right. It's adapting to the LongCoT format, incorporating the reasoning elements, and just getting better at making those long chains of thought.
Got it. So we have the intro to LongCoT in stage 1, and then the practice in stage 2. What's the final test?
Stage 3 is where it gets really interesting. It's called LongCoT Online Training, and they use reinforcement learning to make the model even better. They use something called direct preference optimization, or DPO.
Reinforcement learning can be pretty complicated. Can you break down DPO for us?
Sure. Imagine you show the model 2 different solutions to a problem. It has to choose which one is better based on your feedback, kind of like a thumbs up or thumbs down system. And over time, it gets good at predicting what you like, and that helps it learn.
So it's all about getting the model to think the way we do.
Exactly. And they found that this simple approach actually worked better than some of the more complicated reinforcement learning algorithms. It seems like DPO is really good at handling all the noise and uncertainty that comes from LLMs.
That's interesting. It challenges what I thought I knew about these algorithms.
Yeah, it shows that we still have a lot to learn about AI and that sometimes the simplest solutions work best.
So we've talked about the process, but how well does Bolt actually work? Did it get good results?
The results were really impressive. They tested Bolt on a bunch of benchmarks like ArenaHard MT Bench, Wild Bench, ZebraLogic Math 500. These cover all sorts of problems, from real-world coding to logic puzzles to tough math problems.
So they put Bolt through the ringer.
They did. And Bolt made the LLMs way better even when they use different size models. So it looks like it's a solid method that works in a lot of situations.
And to be clear, this was all without using existing LongCoT models or tons of data that was labeled by humans.
That's right. Which means Bolt could make powerful AI reasoning available to more people, which could have a big impact.
So before we move on to what this all means for the future of AI, let's dig into how they did this research. They mentioned something called ablation studies, right?
Yeah, ablation studies are like controlled experiments where you take out different parts of a system to see what happens. It's a way to figure out which parts are really important and which ones aren't.
So with Bolt, what were they trying to figure out?
They did a few different ablation studies. One looked at the different reward models they used during the online training. They were trying to figure out which feedback systems worked best with DPO.
And they found that DPO did surprisingly well, even compared to those more complex reinforcement learning algorithms.
Right. Another one focused on the LLM they started with. They wanted to see if they could start with a totally untrained model, one that hadn't learned to follow instructions.
Like comparing recruits with basic training to those who have no training at all.
Exactly. And they found that Bolt still worked even with the untrained model. It wasn't as good as with the instruction-tuned model, but it still did pretty well.
So Bolt can unlock reasoning even in models that haven't been taught how to reason. That's cool.
Yeah. And then maybe the most interesting one looked at the online training algorithm itself. They wanted to make sure DPO was the best choice, so they compared it to other algorithms like Reinforce RLLU and even PPO, which is usually considered a more powerful approach. DPO still won. The other algorithms even PPO couldn't do as well, which is weird because you'd think a more complicated algorithm would work better.
So why would a simpler algorithm like DPO beat something as fancy as PPO?
They think it's because DPO is good at handling the messiness of the feedback coming from the LLMs. These LLMs are still being developed, so what they say isn't always accurate or consistent.
So the feedback isn't always perfect.
Right. DPO is good at filtering out the bad feedback and focusing on the good stuff.
So it's like DPO is pickier about what it learns from.
Yeah. It shows that it's not enough to just choose the right algorithm. You have to know how to use it right with LLMs.
This is all super interesting, but I want to hear what this all means for the future of AI. We've talked about how it works and the results, but what does it all mean? That's what I'm really excited to talk about.
Me too. Let's talk big picture. One of the most exciting things about Bolt is that it could make AI more accessible. If we can make powerful LongCoT models without needing all those expensive resources, it opens up a ton of possibilities for researchers and developers.
It's like it levels the playing field, so smaller teams and even individuals can work on this stuff.
Exactly. And with more people working on it, who knows what kind of amazing solutions we'll come up with.
I can imagine a future where LLMs aren't just tools, but partners that can help us solve problems, make discoveries, and even be more creative.
That's definitely possible. But we also need to be careful about the risks as AI gets more advanced. Bolt itself isn't good or bad, but how people use it could have a big impact on society.
That's a really important point. We need to make sure we're developing AI responsibly. But I think it's safe to say that Bolt is a big step forward in understanding how to make machines think like humans.
I agree. And it's cool that all of this came from a paper about a specific technical problem, how to train LLMs more efficiently. It shows that even small discoveries can lead to bigger ideas.
That's science for you. Every discovery can lead to something new and unexpected.
Right. And with Bolt, those new things could be really big. We've talked about making AI more accessible, new ways to design models, even how this connects to how humans think. But what about the real-world applications? Where could we actually see Bolt being used?
Yeah, where could we see it making a difference?
I think the possibilities are huge, and we're just getting started. One area I think we'll see a lot of stuff happening is education. Like, imagine LLMs that can adapt to how you learn, give you personalized feedback, and even change the lessons as you go.
So it's like having your own tutor who's always there and knows exactly what you need.
And it could help people who don't have access to good schools too. But it goes beyond education. Think about healthcare LLMs that use Bolt, could look at patient data, help with diagnosis, even recommend treatment plans.
We already have AI tools for medical imaging and drug discovery, but Bolt could make them so much better.
And it's not just about improving things we already have, It could lead to totally new things we haven't even thought of yet. Like in science, LLMs could analyze huge data sets, find patterns, and come up with hypotheses that would take scientists years to figure out.
Like a research assistant that can handle all the data and point us in the right direction.
Exactly. And what about creative stuff like writing music and art? LLMs could help artists come up with new ideas, try new styles, even get unstuck when they're blocked.
I've seen some cool AI-generated art and music, but Bolt could take that to a whole other level.
And the more I think about it, the more I realize that Bolt is really about helping humans, not replacing them.
It's not about AI taking over. It's about AI and humans working together.
Right. Imagine a world where AI helps us be more creative, understand things better, and solve the world's biggest problems. That's the future I think Bolt is leading to.
That sounds amazing, but also kind of scary. It's going to be interesting to see how it all plays out.
It is. And as we develop AI, it's important to talk about the good and the bad and make sure we're doing it responsibly.
For sure, AI is powerful, and we need to make sure it's used for good.
Well said. Okay, so we've talked about the big picture. Now let's get back to the details. I think our listeners want to hear more about how Bolt actually works.
Yeah, let's get technical. Let's start with that first stage, LongCoT data bootstrapping. Remember, that's where they use a few LongCoT examples to teach a regular LLM how to make those longer chains of thought.
Right, and they use this technique called in-context learning. Basically, they give the model a few examples of the output they want before giving it the actual input.
Like showing someone how to shoot a free throw before they try it.
And the crazy thing is that just 10 examples was enough to make the model much better at giving those long, thoughtful answers.
That's powerful. Just a few examples can unlock so much potential.
Yeah, it shows that these LLMs aren't just memorizing things, they're actually learning how to think.
Okay, but let's break it down step by step.
Yeah.
They start with Llama, right, which is already trained on instructions.
Right. So they take Llama and show it these carefully chosen LongCoT examples. But they're not random examples. They pick examples that show the key parts of LongCoT reasoning, like how to analyze a problem, plan things out, consider different options, and reflect on the process. Basically all the stuff humans do to solve problems.
So they're giving the model a set of tools to think with.
Exactly. And they don't just throw these examples at the model, they put them right into the prompts. So every time the model gets a problem, it also gets these examples of good reasoning.
So they're constantly reminding it what good thinking looks like.
Right. And because Llama is already trained on instructions, it can use these examples and start giving answers that look like LongCoT reasoning, even if they're not perfect.
So it's like it's trying to copy the way those examples think.
That's the cool thing about in-context learning. But they don't just take any output from Llama, they filter the responses to make sure they're only keeping the good ones.
So they don't want the model to learn from bad examples.
Right. This filtering had a few steps. First, they used some basic rules to get rid of responses that weren't in the right format. Then they used something called an outcome reward model, or ORM, to check how good the final answers were.
So they have another AI judging the answers of the first AI. That's wild.
It is. The ORM was trained to tell if the answers were accurate and made sense. It's like a quality control system, making sure only the best responses make it into the data set.
Like a panel of judges picking the best contestants?
Exactly. This filtering was really important for making a good data set for the next step. They call this data set de-bootstrapping, and it's full of these carefully chosen examples of Llama trying to do LongCoT reasoning.
So they basically made a data set of reasoning from an LLM that was itself learning from a few examples, like a chain reaction.
Exactly. And they use this de-bootstrapping data set for the next stage, LongCoT Supervised Fine-Tuning.
All right, so we're halfway through our time today, and I want to hear how that next stage works, but let's save that for next time. Join us next time as we finish this deep dive into Bolt and see how this could change the future of AI. Welcome back to AI Paper Podcasts. So last time we were talking about Bolt, this new way to train LLMs to reason better, and we left off talking about de-bootstrapping. That data set they made using these instruction-tuned LLMs and some really specific examples of long chain of thought reasoning.
Yeah, and that de-bootstrapping data set is what they use for the next step. It's called LongCoT Supervised Fine-Tuning.
So now we're moving from that intro phase to like a more serious training program.
Exactly. They take the de-bootstrapping data and use it to fine-tune a new LLM.
Yeah.
And it doesn't have to be the same model they use for the bootstrapping. They actually tried this with different models and sizes to show that Bolt is flexible.
So it's like taking what they learned in boot camp and applying it to a different branch of the military. The skills are the same, but what they do with them is different.
Great analogy. And in this fine-tuning, there are two main goals. First, they want the LLM to get really good at the LongCoT format. Making those long chains of thought should be easy for it.
It's like teaching a musician to improvise.
Yeah.
They know the basics, but now they have to learn to think and create in that style.
Exactly. And second, they're pushing the model to use those reasoning elements, analyzing, planning, branching, reflecting, all that stuff. It has to become part of how it thinks.
So it's not just about how long the chain of thought is, it's about how well it reasons.
Right. They're training the model to be a smarter thinker that can solve complex problems, more like a human. This stage gives them what they call an initial LongCoT model, which they call 0.
0 go. Got it. Okay, so there's one more stage in Bolt. Tell me about this last step.
This is where it gets really cool. The third stage is LongCoT online training, and this is where reinforcement learning comes in. They use direct preference optimization, or DPO, to make the model even better.
We talked about DPO before. It's like showing the model 2 answers and letting it learn which one is better based on our feedback.
Exactly. And they chose DPO because it's good at handling all the noise and uncertainty that comes with LLMs.
So it's like training a dog when there's a lot of distractions going on. DPO can ignore the distractions and focus on the important stuff.
Perfect analogy. And for this online training, they use a bunch of tough prompts from open source data sets. It's like giving an athlete a hard workout to help them improve.
I can picture it. The model is in the AI gym, sweating and getting stronger.
And they don't just do this once, they do it over and over again, constantly pushing the model to get better at reasoning.
It's like a never-ending training montage.
Yeah.
Okay, so we talked about the results before, but can you remind us what they found?
They found that Bolt made LLMs way better at a bunch of different tests, which shows that it's good at teaching them to reason more like humans.
And all of this without needing those expensive LongCoT models or huge data sets that humans had to label.
That's right. It means that more people could have access to powerful AI reasoning, which is really exciting.
It's amazing that it all started with this idea of bootstrapping, using a few examples to unlock the model's ability to reason in a complex way.
It shows that you don't always need more data or more computing power. Sometimes you just need to be clever.
That's a good lesson. So as we wrap up this deep dive into Bolt, I want to leave you with a question. If we can bootstrap reasoning from a few examples, what else could we teach AI using similar methods?
That's a great question. And I think it's a question that's going to drive a lot of research in the future. If we can figure out how to train AI efficiently, the possibilities are endless.
It's an exciting time to be working on this stuff. And Bolt is a perfect example of the progress we're making. Thanks for joining us on this deep dive into Bolt, and we'll see you next time on AI Paper Podcasts for another look at the cutting edge of AI research.